Hey everyone! In this video we will be looking at the first kinematics equation, v is equal to u plus at. In this equation, v is the final velocity, u is the initial velocity, and a is the uniform acceleration, and t is the time interval in which the acceleration acts on the object. Let us take a car moving with a uniform velocity u. This means that the car will travel a displacement of u meters in 1 second. Why? Well, velocity by definition is rate of change of displacement with respect to time, which means that we take the ratio of the total displacement and total time taken to find the velocity of an object. Let us take an example. If the car travels 10 meters in 5 seconds, then when we divide the displacement by time, we get the velocity as 2 meters per second. We can cross-verify this by seeing how far the car will go for 5 seconds with this uniform velocity. We would get the displacement to be 10 meters. Great! Now that we have a clear visualization for velocity, let us look at the visualization for acceleration. Acceleration is the rate of change of velocity by definition. This means that for uniform acceleration, the amount of change in the velocity of the object per second is called the acceleration of that object. Let us say that a car has a velocity of 5 meters per second in the first second. That means the car travels a displacement of 5 meters in that second. In the next second, we will only accelerate the car at a uniform rate of 2 meters per second, but we will not calculate the velocity as during acceleration the velocity goes on changing, and we are currently interested in the velocity after the acceleration is over. So, after the acceleration is completed, we will again measure its velocity by calculating the displacement traveled by the car in the third second. We notice that the new velocity of the car is 7 meters per second, or the car travels a displacement of 7 meters in 1 second. We can observe that the additional velocity is the magnitude of acceleration per second. Remember, the first and the third seconds are before and after acceleration time intervals, and has no significance in the equation. Awesome! We have understood the visualizations of both acceleration and velocity, and now it is time to bring it all together to understand the equation for the final velocity in terms of the initial velocity and the acceleration. For better understanding, let us consider an example. A car is moving with an initial velocity of 3 meters per second, and the car undergoes a uniform acceleration of 2 meters per second squared for a time interval of 5 seconds. Let us see what will be the final velocity of the car. Before starting the timer, if we measure the velocity of the car, then we would find that the car travels a displacement of 3 meters in 1 second. Now, we will start the timer and apply acceleration to the car. During the first second, the car will gain a velocity of 2 meters per second. If we stop the acceleration and measure the velocity with our usual definition, we would find that the car now travels a displacement of 5 meters in 1 second. During the next second, the car will again gain a velocity of 2 meters per second. If we stop the acceleration and measure the velocity as the displacement per second, we would find that the car now travels a displacement of 7 meters in 1 second. So, for every second the velocity increases by a magnitude of 2 meters per second, and finally when the acceleration stops after 5 seconds, we notice that the final velocity would be 13 meters per second, which would be the sum of the initial velocity 3 meters per second plus the acceleration 2 meters per second squared times the time interval 5 seconds. Thus, we get the required equation for the final velocity as v is equal to u plus a times t. But what about when the acceleration is negative, or if the direction of velocity and acceleration are opposite to each other? Then, just like positive acceleration, the negative acceleration changes the value of the velocity every second, but instead of increasing or adding to the initial velocity, it decreases the value of the velocity, or the acceleration is subtracted from the velocity every second. Thank you for joining me in unraveling the mysteries of the first equation of kinematics. If you found this video informative and helpful, don't forget to give it a thumbs up. Share it with your friends who might benefit from this knowledge, and if you haven't already, be sure to hit that subscribe button and ring the notification bell to stay updated on more exciting explorations into the world of physics.